What's up, you guys? This is page 5, lesson 1, activity 1, and we're going to continue the conversation from the getting started. So if you haven't done that video yet, go back and watch it. Maybe the link is in the description. Maybe not, just follow my channel and see where you've seen things on our Google Classroom where I've posted your materials, and go back and watch it because the conversation from lesson 4, from page 4, is definitely used in this one. Connecting scenarios and their graphs. An important skill for us, let's take a look at it. An important skill for us is to be able to read a situation, understand which quantity described is the independent quantity and which one is the dependent quantity. Of course, quantity is like a number, but you could also say the word variable. And then we want to be able to describe, is that relationship one that's increasing, decreasing, staying level, maybe it has like a dip and then it climbs again. And of course, everything goes from left to right because on our graph, the left part of the graph is 0. There's like a y-intercept there. And we want to talk about how the graph changes from left to right. So there's like a forward movement in time from here to here. While a person can describe the monthly cost to operate a business or talk about a marathon pace a runner ran to break a world record, graphs on a coordinate plane enable people to see the data. Graphs relay information about relationships in a visible way. So you can use lines or smooth curves to represent relationships between points on a graph, and in some problem situations, not all of the points on the line will make sense. In other problem situations, not all the points will make sense. So when you model a relationship with a line or a curve, it is up to you to consider the situation and interpret the meaning of the data values shown. So, for this video, but after this video is over, for the following videos, cut out page 13 graphs from A through H, cut them out, have some glue handy, and when we do page 5, page 6, page 7, all the way up to page 9, you're going to be, with me, we're going to be matching, modeling, and describing the independent, the dependent quantities, and then also figuring out which graph makes the most sense, okay? So I'm gonna cut them out after this video is over, but let's go on to the next direction here. We're going to read each of the 8 scenarios in this activity. We're gonna determine the independent and dependent quantities. And reminder, I'm being consistent with my highlight scheme. I'm gonna highlight / circle the independent quantity. I'm going to highlight / underline the dependent quantity. Then we're going to match each scenario to its corresponding graph and glue the graph in the space next to the scenario. So for each graph, we also need to label the x-axis, horizontal, and the y-axis with the appropriate quantities. Because when we talk about coordinates, the important part of a coordinate is x goes first, y goes second. But better than that, independent quantity goes first and dependent quantity goes second. We're going to interpret the meaning of the origin as well. And the origin, I should probably label it on this here. In fact, I'll do it in yellow highlight. The origin is the location where the x-axis and y-axis meet. However, we're going to be talking about it as the independent axis, x, and the dependent axis, y, and where they meet, that'll be the origin, like some sort of 0-0 scenario. Let's do just this first example. Page 5, Daredevil. Grayson completes a dive from a cliff 100 feet above a river. Not underlining, little squiggles. The reason for that is that's information that's going to tell us already the shape of the graph. We should know that the graph is going to be of a certain direction. It only takes him 1.7 seconds to hit the water. So there's some more problems for us. Now I've got my highlights, so that's the first thing I'm going to do. Grayson completes a dive from a cliff 100 feet above the river. And it only takes him 1.7 seconds to hit the water. Between the word second and the word feet, one of them is the independent quantity. Seconds. Because time is usually independent. How many seconds has Grayson been falling in his dive? Well, if you can tell me how many seconds, I'll tell you if he hit the water or not. Because the feet above the river, that is specifically depending on how much time Grayson has been falling. A reminder, you could switch this around a little bit and it would still kind of make sense. So you have to think about it in, if I know he's 50 feet above the water, then I know he's been falling for 0.25 seconds. See what I did? I'm taking the information first and then saying what that information does. Grayson's been falling for about 0.5 seconds, so that must mean that he's now about 100 feet in his fall. Which one sounds better? Which one feels better? In that feeling that smells right, common sense, that's what you need to do. Our independent quantity is seconds in the fall. Dive. He's diving, right? He's trying to be graceful. Therefore, the time spent diving is going to impact our information about how far. The dependent quantity is distance. Time in seconds and distance in feet from the water. Okay? So we have these graphs. Which one of these graphs looks like we're 100 feet in the air and the feet above the water is getting lower and lower and lower? This one would be amazing. It'd be like he started on the ground, he flew into the air, and then he even flew more into the air, and then he leveled off. That doesn't make sense for a dive. This one, he's starting on the ground, and then he's taking off. No. He hit the water and bounced. I hope not. That'd be awful. It could be this one. But have you ever observed things in motion? When you toss something in the air, there's like a moment where it hovers and then it starts to fall back down. And as it falls back down, it's getting faster and faster and faster. This graph isn't the right graph for our Grayson diving scenario, because in this graph, he's already starting really fast. And then as he gets closer to the water, he's like slowing down. In fact, in this graph, he never actually hits the water. So D is right out. It's E, y'all. You see, if he's starting 100 feet in the air, there's his 100 feet up. And then right here, it's been 1.7 seconds. So in this case, 0, 0 would represent 0 seconds, 0 feet off the ground. However, he's going to start 100 feet off the ground because that's the height of the cliff, and then he's going to fall for 1.7 seconds, and when he gets to the 1.7 second mark, he's hit the water. This is the box for our example on page 5. And we're going to continue to the next episode. It's been a rather long video for right now, so we're going to go ahead and tighten it up and clean it up for this one for you, that these other graphs are going to be the graphs we use. But I'm going to do this in the off-camera time. I'm going to glue this graph to this space. I did interpret the meaning of the origin verbally. Maybe that's something that we need to write down before we go. I'm also not acknowledging I need to label the X and Y axes with the appropriate quantity and a reasonable scale. I have some sort of a scale, but I need to put distance with FT next to the Y axis. And I need to put time with seconds, and I don't need that right there. Time with seconds for the x-axis. It could go in this location and could go in that one, or it could go at the top. It's whatever space you have available to. I'm going to call that good. I'm going to say this is the graph for our page 5. Thank you for liking, commenting, subscribing, and of course for watching. I hope you've learned something along the way and you're ready to learn more. In fact, if you really feel confident that you know what's going on here for these examples, don't even watch page 6, 7, and 8, and 9. Do it yourself. But if you get stuck and you get out of sorts and you can't figure it out, come back and watch them. And I'll see you in the next page 6 episode.